So for our first example, we're going to look at Chapter 9, and we're going to look at problem number 33. Okay, so we have a little hockey puck here that is going along a frictionless surface at, let's say, 10 meters per second. And then we apply a 5 Newton force in this direction for a period of time of 1.5 seconds. And then the question is asking, what are the final components of the velocity as we do this? So let's go ahead and take a look and see what happens to this. Now, because these are vector quantities, they operate independently in their directions. So we're not changing the x velocity of this. You know, if I put my coordinate system here, x and y, I'm not changing the x velocity, I'm just changing the y velocity. So if I push on it this way, that's going to cause it to move off in some new direction. It'll have the same x component of the velocity, but we'll be adding a y component to the velocity. So since we know how long this force is interacting for, we know this is a 5 Newton force, 5 newtons. So let's go ahead and calculate the impulse. The impulse is denoted J, and I can say that's the force times the change in time. So that's 5 newtons times 1.5 seconds. So that's going to be 7.5. And then the units here are kilograms, meters per second. So that's going to tell us the change, the impulse there, but we also know that the impulse is proportional to the change in momentum. So there's, this is where we write down our momentum equations in the two directions. We can say the initial momentum in the x direction is just mvx, okay, because that's the mass of this object times the velocity in the x direction. And then the final momentum is also mvx, because that hasn't changed. In the y dimension, the initial momentum is 0, because it isn't moving in the y dimension, and then the final y velocity is mvy, because we now have a velocity in the y direction. And we know that the change in impulse, or the impulse, is proportional to the change in the momentum. So if I look at the final momentum, mvy, minus the initial momentum in the y direction, that's just mvy. That's going to be equal to our impulse, but our impulse is just this f times delta t. So I can go ahead and calculate my velocity here, and that's going to be f delta t over m, and that's 5 newtons times 1.5 seconds divided by 0.15. Oh, I forgot to write down that the mass of this is 150 kilograms. So 0.5 kilograms. This is in newtons. This is in seconds. And that's going to give me the appropriate units of meters per second. And I wind up with 50 meters per second. Because I have an extra factor of 10 down here. Those are going to cancel. Wind up with 50 right there. And the velocity in the x dimension is unchanged. So that means that our Vx is still 10 meters per second, and my Vy is equal to 50 meters per second.